This video lesson is on Chapter 6, Section 8, which is called the counting principle. So there's two vocabulary words we need to know for this section. We have the vocabulary of a tree diagram, which you may or may not be familiar with, which is one way to count the number of possibilities. A tree diagram uses branching to list choices. So I'll show you an example of this on the next page. The second is the counting principle. The counting principle uses multiplication to find the number of ways two or more events can occur. So both of these can be used to find a list of choices or how many events can occur in the number of different combinations of ways. You may have thought before, maybe making a sandwich, I can pick wheat or white bread, I could pick turkey meat, I could pick ham or roast beef, and then I could pick 3 different types of cheeses. Well, how many possible combinations are there? So these are going to help you figure that out. So let's go over making a tree diagram. So you are choosing a birthday cake. It can be either round or rectangular, and it can have vanilla, chocolate, or lemon for the cake flavor. How many different cakes are possible? I'm sorry for my typo. So we have first in our tree, we would put our round and rectangular in the cake shapes. And then from the round, we can have 3 different flavors. We can have vanilla, chocolate, or lemon. And we can have the same for the rectangular, vanilla, chocolate, or lemon. So now we can list all of our possibilities. We can have a round vanilla, a round chocolate, a round lemon, or rectangular vanilla, rectangular chocolate, rectangular lemon. So that leaves us with 6 different cake options. So what I'd like you to do is suppose now you have the choice of icing. So you can have buttercream, cream cheese, or whipped frosting for the cake in example 1. So still working here. Copy the tree diagram above and then add the new choices. How many possible choices for a birthday cake do you have now that you have to choose between the 3 different types of icing? So press pause now and give that a try. So example 2 is now using the counting principle. So you are choosing a 4 character, which can be a number or a letter. So the characters can be either lowercase letters or digits. Using the counting principle to find the number of different security codes that are possible. So in this case, there are 26 different letters in the alphabet, and we have 10 different numbers because we count 0. So 1 through 9 plus 0. So a total of 36 choices. So we're going to set it up where we have the number of choices for the first character, so we can be any one of those 36, the second, any one of those 36, the third, any one of those 36, and the fourth, 36. What we do is we multiply the numbers for the first character, the number of choices for the first, the number of choices for the second, number of choices for the third, and number of choices for the fourth to get the total number of choices. So in this case, it's over 1,679,616 different choices for your security code. So what I'd like you to try now is you are choosing a computer password that has 2 uppercase letters followed by 4 digits. Use the counting principle to find the different passwords that are possible. So you can set it up similar to here, but now your first 2 choices have to be uppercase letters, and the last 4 have to be a digit. So go ahead and try this, and we'll go over this one tomorrow because it's a challenging one. So example 3 is finding a probability. So your school is issuing 5-digit identification codes and numbers to students randomly, but the first digit can't be 0. What is the probability that your identification number is 54321? That would be pretty awesome and easy to remember. So first, you need to find the number of different identification numbers possible. Because the first can't be a 0, there are 9 choices for the first digit and 10 for each of the others. So 9 times 10 times 10 times 10 times 10 is 90,000 choices. Then find the probability that your identification number is 54321. Well, that's 1 out of 90,000. So the probability that you're going to have that is 1 in 90,000 numbers issued. So at our school, not very likely since we only have a little over 100 kids. It's not likely you'd get that as your identification code. So you randomly choose a 7-digit code to open your garage door. What is the probability that you choose the code 1, 2, 3, 4, 5, 6, 7? So go ahead and use the same principle to find the probability that that's what you would pick randomly for your code to be. And that's all for this lesson. So press pause, give it a try, and then you're done.